Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. The previous lesson established that when a parent renders, its children render with it. This one is about the way out of that, and it is not memoization. It is where you put things. By moving one piece of state down or by passing content in as a prop instead of writing it inline, you can stop re-render from reaching a subtree at all with no comparison function and nothing to remember. The reason it works is a single fact about element identity, and once you have it, the 4 patterns here stop being tricks and become obvious. Here is the situation, and it is extremely common. A component holds a piece of state that only a small part of it cares about, an input value, a toggle, a hover flag. Below it sits something expensive, a long list, a chart, a table. The state changes on every keystroke, the component re-renders, and the expensive thing re-renders too, because it is a child and that is what children do. Nothing is wrong with the code. The structure is wrong, and no amount of tuning the expensive component fixes a structure that reruns it for a reason unrelated to it. This is the important one, so let me give you the mechanism rather than the recipe. Move the state into a small wrapper component and pass the expensive part into it as children. Now when the wrapper state changes and the wrapper re-renders, look at where the children element actually came from. It was created by the component above during that component's render, and that component did not re-render. So the wrapper receives the exact same element object it had before. React compares them, sees the identical reference, and skips the whole subtree. The children did not render because there was nothing new to render. That is not React being clever about children, it is ordinary reconciliation acting on an element that was never rebuilt. The children prop is one slot. When you need several, pass them as separate props, a header, a sidebar, a footer, each receiving an element. The mechanism is identical because children was never special. It is just the prop that JSX fills in from what sits between the tags. Any prop holding an element gets the same treatment. This also tends to produce a better component because the slots are named in the signature and you can see at a glance what this layout is composed of. The cheapest version of all of this is not to lift the state in the first place. Keep each piece of state in the smallest component that needs it. A search box that owns its own input value re-renders only itself. The habit that causes the problem is lifting state up by default out of a vague sense that higher is more flexible. Lift it when 2 components genuinely need to share it, which is the rule from the state lesson, and leave it where it is otherwise. Most performance problems of this shape were created by a decision, not by React. The inverse move for when the state genuinely belongs where it is. Take the part that changes and pull it into its own component so the state moves down with it. Now the frequent re-render happens inside a small component and the rest of the tree is untouched. Between collocation and extraction, you can usually get any subtree to stop re-rendering purely by changing which component owns what. The comparison on screen is right, and it is worth saying why in mechanical terms. Memoization adds a comparison on every render and only pays when that comparison succeeds. And it succeeds only if every prop is stable, which usually means more memoization upstream. Composition removes the render instead of comparing it, costs nothing at runtime, and cannot go stale. One correction to the framing, the same one as the memoization lesson. The React compiler is a separate opt-in build tool, not something React 19 switches on, and this project does not have it installed. That does not weaken the argument here. It strengthens it because composition works identically with or without a compiler, and it is the one optimization you never have to ask that question about. When a parent renders, its children render, unless the element was created somewhere that did not re-render. Passing content in as children or as a slot prop is what makes that true. Keep state in the smallest component that needs it and extract the part that changes when it must live where it is. Reach for composition before memo because it removes the work rather than measuring whether the work is needed. The parent holds an input state and renders an expensive list inline in its own markup. Type in the box and watch the list's render counter climb with every keystroke. The list receives nothing that changes and does not care about the input at all, and it re-renders anyway because its element is being rebuilt by the parent's render every single time. This is the shape of the problem, and it is worth noticing how reasonable the code looks. There is no mistake in it, only a structure that ties two unrelated things together. The same two things rearranged. The state moves into a small wrapper, and the expensive list is passed into it as children from the component above. Type now and the counter does not move. The wrapper re-renders on every keystroke exactly as before, and the list does not because its element object was created one level up in a component that did not render. Same components, same state, same number of keystrokes, and the expensive work has simply stopped happening. No memo, no use callback, no dependency array to keep correct. The last variant is the collocation and extraction argument at slightly larger scale. Several pieces of state, several regions, and the demo lets you see which parts re-render as each piece changes. Read it looking for ownership rather than for syntax, which component holds each piece of state and how far the consequences of changing it travel. Then try the thought experiment that makes the lesson stick. Move one piece of state up a level in your head and work out which additional components would start re-rendering. That is the whole cost model, and once you can run it in your head, you will place state correctly the first time far more often than not. The model to keep is that a re-render travels down the tree, and an element passed in as a prop was not built by that render, so the travel stops there. Everything in this lesson follows from that one sentence. Put state where it is used, pass expensive things in rather than building them in line, and reach for memoization only when the structure genuinely cannot be changed. Structure is free and it does not go stale. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.